Today you're going to learn a little bit about plastics and how they're made. Almost all plastic names start with the word poly, poly meaning many. These two here are made of polyethylene. There are two types. This one's called low density, it's kind of soft. This one's high density polyethylene, rather rigid. This one is polypropylene. A little bit clearer than polyethylene, very durable. Over here we have plastic that's almost clear like glass, and this is called polystyrene. You're more familiar with polystyrene in this form, where it's a foam called styrofoam. Polystyrene became styrofoam. On the end here I have, this is a pipe, very commonly used in home plumbing, irrigation systems. It's abbreviated PVC, polyvinyl chloride is the official name of that plastic. Sometimes you can tell what the plastic is by looking at the code. It has a recycle code on the bottom. Here you can see a number 5 with the letters PP for polypropylene. Here it says 4 LDPE, low density polyethylene. So today you'll learn about the molecular structures of some of these plastics and how they're put together by a process called polymerization. Polymerization. Today the lesson focuses on double bonds. Yesterday you were told to remove these ones that had the corner notches. Today you need them. When you make a double bond, you'll line up atoms on a diagonal like so. This carbon atom and this oxygen atom are now sharing 4 electrons, 2 pairs, and that's a double bond. You should see that for the oxygen, that takes care of all the valence electrons. This carbon, on the other hand, still has 2 slots to fill, so it's not a molecule until we fill those slots. Here's a hydrogen filling that slot. Here's another hydrogen filling that slot. So now this is a complete molecule, carbon bonded to 2 H's and double bonded to oxygen is formaldehyde. You may have heard of that molecule. It's used to preserve dead bodies. To show this on paper, you can do it on this nice diagonal if you have the skill, but usually you just show a carbon and an oxygen, and in between them there are 4 electrons. So something like this is a reasonable way to represent that double bond. You can see the oxygen also has these non-bonding electrons here. So that makes what's called an octet for the oxygen, 4 on the left, 2 on the top, 2 on the bottom. And this carbon you can see is making bonds with hydrogen. So if I use the same kind of system, here's an H sharing a pair of electrons with the carbon, that's this one. Here's another H sharing a pair of electrons with the carbon, that's this one. That's a reasonable representation of this molecule on paper. You'll remember lines represent bonds, so here if you see something that looks like an equal sign, that's a double bond. So this is not carbon equals oxygen, this is C double bonded to oxygen. And then up here there's a single bond, and over here is another single bond. So that all these mean the same thing. These are 3 different ways of representing the structure of a molecule. With the 3-dimensional models, use the color code. carbon, oxygen, hydrogens. You can see I've got straight pegs for the carbon to hydrogen, and I'm using the arched pegs to represent the double bond here between carbon and oxygen. You can make three-dimensional models of molecules that contain double bonds. The most common elements that make double bonds are carbons and oxygens. You can make a double bond between carbons. That's very common. And as you've seen, you can also make a double bond between carbon and oxygen. Also very common.
For assignment 6.2, much like 6.1, you'll be using the Lewis dot simulator.
Except for this time you'll be using some double bonded pieces. Not all of the pieces you use will require this double bond, but some of them will. To use the double bonded pieces, you'll pull one out. We'll pull another one out. And if we click it around, we're going to line up the two dots on either side and fit them together like so. And you'll hear the clicking sound, and you'll know that you've made a bond out of them. Sometimes the molecule only requires one double bond, and then maybe the rest is filled with other atoms that are only single bonded. So again, you're just going to make molecules until you get that little score and you hear that fun sound that says that you have made a full molecule, and the bond breaking energy works the same way. If you need a carbon that creates two double bonds, you need to use this special carbon on the end here that you can put a double bond on either side of it. When you've made a molecule for the assignment, take a screenshot and insert that into the document.
When you scroll down, you'll see the three-dimensional models. You'll build this with your model kit first, insert a picture, and then you'll do the three-dimensional drawing using the dashes and wedges if anything is going in or out of the plane.